more things left. Now we're going to find these terms, but these terms are based on a recursive rule. And y'all, recursive is just a fancy word for looking at the previous term. So the rule is based on the previous term. We know the first term is 25. To find a sub 2, all we're going to do is do 25 minus 5. 25 minus 5 is 20. There's our second term. How are we going to get the third term? To get the third term, you look at the answer from the previous term, just minus 5. So the answer for a sub 3 is 15. What about a sub 4? To get a sub 4, you literally just look at a sub 3, which is 15. Take away 5, that's going to be the answer. That's how you write the recursive pattern given this recursive rule right here. This is a recursive rule. I know it's a recursive rule because it has this notation right here. Now and next. That's all that means. Now, in part 3, we were going to use the recursive rule, and the instructions also say to write the regular rule. Guys, all these minus 5s, that's going to be the number in front of letter N. So to write the regular rule, not the recursive, it is going to be negative 5n, and then don't forget you always have to adjust something. So let's see. I think I'll just take a look at this right here to figure out what the adjustment is. So I know a sub 4 equals 10. I also know it's going to be negative 5 times the fourth placement. Now, negative 5 times 4 is negative 20. What would I have to add? What would I adjust to get a value of 10? What would make this a true number sentence? Yeah, that's right. Plus 30. Plus 30 here. Plus 30 here. And then that's it. That's the regular rule. Let's take a look at number 8. Very, very similar, guys. So again, you've got your recursive rule here. I know it's recursive because of this notation. So drop that 15 down. Go ahead and add 3. A sub 2 is just 18, y'all. Then take that 18 and add 3 more to it. So a sub 3 is 21. And guess what we're doing with this 21? We're adding 3 to it. So a sub 4 is 24. And recursive rules, they're always the same, guys. Whatever we're adding or subtracting is going to be the number in front of the letter N. So this is going to be 3n, and then we need to find an adjustment. Just for fun, I will pick a sub 2. So a sub 2 means I drop 2n for that letter, but I need to adjust something because it should equal 18. This is only 6 plus 12. That's it, right? Plus 12, and then let's move on. All right, so that was problem 8. All right, guys. Let's talk about factorials. They look weird because they're denoted with an exclamation point, but it's easy. All right. So what a factorial means is that you take the highest number of 10 and you literally multiply it by every single whole number down to 1. And it's used for permutations to find all the possible combinations and probability. That's what factorial is used for. So there's the top expanded out. Let's go ahead and expand the bottom. So for 2 factorial, it's just 2 times 1. But 8 factorial is going to start with 8 and go all the way down to 1. 8, 7, 6, 5, 4. Guys, if I ever throw you a test or a quiz question on stuff like this, it's really just testing to make sure you know how to simplify fractions. That's all it is. Because look, there's an 8 here and an 8 here. Those are going to cancel. There's 2 7s. In fact, all of this cancels. So the only thing that's left, the 10 and the 9 up here, they didn't have anything that canceled out. So 90 is going to be on the top. And remember, we had a 2 times 1. Those didn't have a set at the top either. So the answer, number 9, is just 45. That's all it is. 90 divided by 2 is 45. Let's take a look at number 10. All right, so for number 10, guys, remember, this is 6 times 5 times 4 times 3 times 2 times 1. At the bottom, this 3 is going to be 3 times 2 times 1. This 4, guys, is going to be 4 times 3 times 2 times 1. So if all of these cancel out, which they do, it's just going to be 30 divided by 6. So number 10 is just 5. Ooh. Let's look at number 11. So for problem number 11, we actually have 2 things at the top. So number 11 is going to be 5 times 4 times 3 times 2 times 1. And then, of course, 2 factorial is just 2 times 1. 7, 7, 6, 5, 4, 3, 2, 1. Look, here's a big chunk that we can cancel out right here. So what does that leave? That leaves 2 over 42. And of course, y'all, we're going to not box that in. We're going to simplify. So the answer is just 1 over 21. Y'all, take a look at number 12. Number 12 has been throwing kids for a loop. So on number 12, before we work number 12, just look up here. Just watch me. All you gotta do is watch me, guys. Let's say I have 3 factorial over 4 factorial. That's 3 times 2 times 1 on top. And then it's 4 times 3 times 2 times 1. What does that simplify to? Just 1/4, that's right. Let's do it again. What if I had 6 factorial on top, but 7 factorial on the bottom? Remember, this is 6, 5, 4, 3, 2, 1. This is 7, 6, 5, 4, 3, 2, 1. What's that turn into? 1/7. Very good. So, on problem 12, you have some integer on the top, and then you have 1 greater at the bottom. So remember what is happening. Hold on, let me go back. Do you guys agree that these 2 are congruent? Are those congruent? 3 times 2 times 1, 3 times 2 times 1. So this 4 has a 3 factorial hiding out in it. That's what that is. So this right here, I can rewrite this because it always has that. This is 7 times 6 times 5 times 4 times 3 times 2 times 1. Here's where they all match. Here's where it was 1 greater. right here. Here's where they all matched. This is like your n factorial, which means that's also n factorial, and there's your 1 greater. Y'all, the answer to this is just 1 over n plus 1. And that's it. That's going to wrap up today's stuff.